I would like to introduce Brynn Sherman. Brynn's an assistant professor at The Ohio State University. She just launched her lab this fall, which is why there are no books on the shelves yet. She received her BS in Neural Science from New York University in 2016 and completed her PhD in psychology at Yale, followed by a postdoc at University of Pennsylvania. Brynn's work combines insight from human behavior, neuroimaging methods, and neural network models to answer questions broadly related to human learning, memory, and of course, time perception. And time perception is what she's going to be talking about today. So I will turn over the floor. Brynn, you can go ahead and bring your slides up.
All right, that looks good.
Looks good to me. Yep.
Okay, great. Awesome. Well, I'm really excited to be here. Thank you so much for having me. Was just said, a lot of my work is about time perception and temporal memory, but I'm really coming at this from the expertise and from thinking about it really from the angle of memory. So it's really awesome to be able to present to a broader audience here and an audience that really has a lot of expertise in time itself. I don't think my talk will take the whole time, so I'm excited to have a lot of time to engage with you all and especially get some thoughts as towards the end, I'm going to be talking about some future directions. But okay, so to jump in, I am going to be talking today about this new illusion of time in memory that we discovered that's caused by repeated experience. And the sort of overarching question that is driving this research program here is quite a broad one, which is how do we remember when something occurred? And I suspect that a lot of you can appreciate that the answer to this question isn't trivial. It's often quite challenging for us to pinpoint when exactly in time our memories happened. And part of what I want to argue today is that our experience of time, at least in memory, is not veridical, but rather our memory for time is illusory. And what I mean by that is that our experiences are not necessarily encoded with explicit timestamps that tell us how long something lasted or when exactly something happened in memory. We often have to use inferences from memory or from other aspects of our experience to get a sense for time after the fact. And I say this in part because we know that our sense of time can be distorted by a wide range of factors. So for example, things like emotion and surprisal can lead to these big dilations for specific moments of time. Things like event structure, so how it is that we carve our continuous experience into discrete events, can really powerfully influence our sense of time, both in sort of the immediate term perception of time and also in longer term temporal memory. Things that are intrinsic to the stimuli themselves can also influence our sense of time. So how memorable a particular image is can make it seem like it lasted longer than it actually did. And then lastly, and what I'll be focusing on today, is that there's a large body of work suggesting that repetition can influence our memory for time. And so this is what I'm going to be focusing on today, which is this question of how does repeatedly encountering information affect our memory for when it first occurred? So how do we, when we encounter something multiple times, how do we look back and think, oh, this was the first time that I saw it? And we were inspired to ask this question in part by our own subjective experience. So just to give you an example, this is kind of a silly example, but I'm sure a lot of you can relate to the idea of sort of being bombarded by redundant headlines day after day after day. So this is just an example of, in the last 2 weeks, different New York Times headlines about various aspects of AI. And so the question that we're going to be asking here essentially is, when did you first hear about ChatGPT or the AI revolution or OpenAI? And the intuition that we had is that when you're constantly being bombarded by this repeating information and you're trying to reach back in your memory to think, when did I actually first encounter this information? It might actually seem like it was very distant in the past, when in fact it might have actually been relatively recent. And so this is the intuition that we were trying to test here, which is that perhaps counterintuitively, repeating information might actually make it seem more distant in your memory. And so to address this question, we designed a very simple paradigm. Participants were just viewing a sequence of images of objects. They were just viewing sort of a continuous stream here. But we designed the sequences in such a way that we could isolate the effect of repetition on memory. So just to sort of go through the actual structure of the sequence here, the sequence started and ended with what I'll be calling these buffer images. These are images that were just shown once. We never even tested memory for these images. They were just to sort of wash out any primacy or recency effects that might be affecting memory. So just the first few and the last few images were just sort of throwaway images. But apart from those buffer images, the entire sort of interior of the sequence here, we're going to be alternating every other image between what I'm going to be referring to as a filler, which are these images with blue backgrounds, blue borders here. And these are images that are only going to be shown once throughout the sequence. And we alternate these with what I'm going to be calling targets, which are with these green borders here. And these are images that are going to be shown 2, 3, or 5 times throughout the sequence. So you can see that there's this little tiger here, and then later on in the sequence, the participant's going to see the tiger again. And critically, we designed the sequence in this way such that every other image was a filler, only presented once, or a target presented multiple times, so that we could basically match points in time of initial encoding. So this bag and this tiger were basically encoded at the same moment in time, just one image away. But critically, the tiger is subsequently going to be repeated multiple times, whereas the bag is not. And so we can compare people's memory for the fillers that only occurred once versus the targets that occurred multiple times to get a sense of whether repetition is influencing their memory. And we can sort of control for the actual encoding time here. So after participants viewed the sequence of object images, we just gave them a memory test where we asked them, did you see this image before? And then when did you see it first? And so they were responding on this timeline here, where the left hand of the timeline would be the very first image they saw, the right hand would be the very last image they saw. And we were always asking them to indicate when they saw it first. So we weren't telling them anything about whether or not an image did repeat. But for a filler here, they would basically be answering, when did you see it? The only time, because that filler never repeated. Whereas for the target, they were answering, when did you see it first, amongst the many repetitions. But again, they weren't aware of the repetition structure. We didn't tell them whether an image was repeated or not. We were just asking them when they first saw it. And so to address this question, we want to compare people's memory for when these fillers, which occurred once, appeared versus the targets. And so what I'm going to plot here is just the median position that participants were across participants that each image was placed along the timeline. So again, the far left of the timeline corresponds to the beginning of the encoding phase. The far right corresponds to the end of the encoding phase. And I'm going to color code the images by when they actually occurred in the sequence. So things that actually occurred earlier towards the beginning of encoding are going to be colored in light blue. And things that actually occurred later in the sequence are going to be colored in darker shades of blue. And so if we first look at memory for the filler images, so again, the images that were only shown once throughout the sequence, you see this really nice gradient of blue along the timeline. So people are roughly accurate. They're placing things that occurred earlier in the sequence as having occurred earlier and things that occurred later as having occurred later. And when we compare this now to memory for the targets, which were presented multiple times, you can see that again, there's this nice gradient of blues, but critically, these targets are being pushed back in time. People are remembering these targets as having occurred earlier in time than their corresponding fillers. So they're sort of remembering it as closer to the beginning of encoding than they actually were. And we can look at this on an individual participant level here. So now what I'm plotting is just the average placement along the timeline for the fillers versus the targets. And you can see that the vast majority of our participants are rating the targets as having occurred earlier in time than their corresponding fillers. And this is what we're going to be referring to as the temporal repetition effect, which is that repeated information is remembered as having initially occurred earlier in time than something which was not repeated but was encoded around the same time. And the next thing that we wanted to do was really dig into the repetition aspect of this temporal repetition effect. So on the one hand, it might just be that when information is repeated, it's just pushed back in time by some constant amount. But another possibility is that this effect is actually sensitive to the number of repetitions, that each additional repetition is going to push back your memory for time further and further. And so we can look at this because the targets were repeated either 2, 3, or 5 times, we can see whether or not the effect scales with the number of repetitions. And indeed, we find that there is scaling here. So the more times information was repeated, the stronger temporal repetition effect. In other words, the further back in time that those images were remembered to have initially occurred. So we see the strongest effect when things were repeated 5 times. And so this here is sort of the basic temporal repetition effect. We replicated this in a variety of ways, and I'm just going to walk you through a couple iterations that we did that I think are particularly informative. So one of the first things that we did was ask whether the temporal repetition effect emerges via forced choice. So what we did here is we just had the exact same encoding phase as I just described in the previous study. But we changed up the memory test. So instead of having people respond on this sort of open-ended, inherently noisy timeline, we gave them 2 images and we asked them to indicate which of the 2 images that they saw first. Critically, the 2 images that we presented to people were always a target and its corresponding filler. So again, this bag here and this tiger that appeared right after it. And because of the way that we design these sequences with the filler, filler, target, what that means is that on 100% of trials, the filler, which was only presented once, is going to be the objectively correct answer because the fillers were always 1 image before the target. And so this provides a really strong test of the temporal repetition effect. So the temporal repetition effect would predict that people are going to indicate that the repeated targets are going to occur earlier than their corresponding fillers, which again, on 100% of the trials is going to be the incorrect objective answer. And so we can quantify this by computing what I'm calling a target bias score, which is basically just the proportion of trials for which the participant chose the target as having occurred earlier in time. So a score of -1 would mean that participants chose the filler as having occurred earlier on 100% of trials. Again, this is the objectively correct answer. A score of 1 would mean that participants chose the target on 100% of trials, which would mean getting the answer wrong on 100% of trials, but showing evidence for the temporal repetition effect. And we found that every single one of our participants, on average, rated the targets as having occurred earlier in time than their corresponding fillers. And we again see that this really nicely scales with the number of times that information was repeated. So even in this sort of different task where we're really pitting these 2 possibilities against each other, we're seeing strong evidence for the temporal repetition effect. Another question that we wanted to ask was whether the temporal repetition effect scales with just the repetitions, like I showed you, or whether it actually depends on people remembering that information was repeated, and does it scale with the number of times that people remember it having repeated. And so in this experiment here, it was pretty much exactly the same as what I described before, except we changed up the task during encoding. So previously, participants were just making judgments about each individual object, in particular, whether or not each object was larger or smaller than a shoebox. But we changed this up now so that it's a continuous memory recognition task. So on every single image, participants at the time of encoding are indicating whether or not they had seen the image before during encoding. And then we just kept the same memory retrieval task where subsequently participants were judging when they first saw the image. And so what this continuous recognition task allows us to do is actually track participants' memory for the repetitions online and relate that to their subsequent temporal repetition effect. So first, overall, we replicated the basic effect that these targets are remembered as having occurred earlier in time than their corresponding fillers. And now we can analyze the data not based on the number of times that information was repeated, but rather on the number of times that participants correctly identified the image as having been repeated at the time of encoding. And you can see that the effect really nicely scales with the number of remembered repetitions. And in fact, if you put the actual repetition structure and the remembered repetition structure, and people's actual empirical remembered recognitions in the same model, the number of remembered repetitions wins out over the true repetition structure. So it seems like this effect really is about people remembering that they've seen an image multiple times. And then the last sort of iteration that I wanted to mention for now here is we wanted to understand whether the temporal repetition effect emerges on the scale of ordinary experience. So we sort of motivated this question by this idea that you're sort of encountering repeated information over the course of days, weeks, or months. And so we wanted to understand whether this effect that we're seeing here on the order of minutes could actually be explaining what our subjective experience is on the order of many days. And so the way that we did this is we basically took the same task as before, except we separated out over the course of 5 days. So over the course of a Monday through a Friday, participants were doing short segments of the encoding task. And they were just doing this over 5 consecutive days. And critically, we manipulated the repetitions specifically across days. So we made a couple different changes to the sequence structure here to just make the task manageable. One is that the targets now only repeated 2 or 3 times. But what that meant is that they would occur either on 2 out of the 5 days or 3 out of the 5 days. So now participants might have been seeing this tiger on Monday, Wednesday, and Friday. And then we brought participants back after a weekend, so 3 days later, and this was all on Prolific, so it was all online data collection. And we then gave them the memory test that fall after the weekend. And so for each image, we had them indicate how many times they think they saw the image, again, so that we could relate the number of remembered repetitions to the effect. And then the same question as before, when did you see it first, and have them respond on this timeline here. And so now, even when these repetitions are happening over the course of 5 days, we still find very strong evidence for the effect that these targets are remembered as having occurred earlier in time than their corresponding fillers. And we again see this nice scaling with the number of times the information is remembered to have been repeated. So things that were remembered to have the items that people indicated having occurred 3 times, regardless of whether they actually did occur 3 times or not, were remembered as significantly pushed farther back in time than something which was only remembered to have occurred once. So just to sum up what I've shown you so far, I've demonstrated evidence for the temporal repetition effect, which is that repeated information is remembered as having initially occurred earlier in time than it actually did. This is a robust illusion emerging across several different variants of the paradigm and operating even at the scale of days. And the effect scales with the number of times the information was repeated or critically was remembered to be repeated. And I think this latter point is particularly interesting. I think it's particularly insightful in terms of the relationship between memory and this sort of illusion of time that we're seeing. But this also might suggest perhaps some deflationary explanations, which is, for one, maybe the temporal repetition effect is just a heuristic. If participants are remembering that they saw something 5 times, they might be thinking to themselves, oh, in order for me to have seen it 5 times within X number of minutes, that first repetition must have been pretty early on in the encoding phase. And so I'm going to push it back and say that it was early. And so we tried to get at whether this heuristic might be actually explaining our results by running a very similar version of the paradigm, the exact same as what I showed you in sort of the first experiment, except we just subsequently probed people about their strategies in the task. So first, we just asked them in an open-ended way, just free response typing, what strategies they used. And I think out of the 50 participants, maybe only 2 sort of spontaneously reported that they used something about the image repetitions to infer temporal position or estimate temporal position. But then in addition to that open-ended question, we also asked people to judge, one, on what proportion of trials did they use their knowledge of image repetitions to estimate temporal position. So trying to get at whether they had any sense for having used that strategy. And then second, we asked them, regardless of their answer to how often they use that strategy, how influential would they say that was? So maybe they would say they only used it on 10% of trials, but when they used it, it was a very influential strategy for them. And then critically, we wanted to relate their judgments on these, their responses on these different questions to the temporal repetition effect. And so these are the data here. So you can see that for both questions, the question about how often they were using this sort of heuristic strategy and how influential that strategy was, there's a huge spread of responses. So some people certainly are saying that they're using their knowledge of the repetitions to infer temporal position. Other people are saying that they're not using that at all. And same with how influential it is. But critically, in both cases, we don't see any relationship between the extent to which people are using these strategies and the magnitude of their effect. So on sort of a strong account of this heuristic idea, you would expect that the extent to which people have insight into this strategy and are saying, oh yeah, I used repetition to make my judgments, you should expect that that would actually predict the extent to which they show the effect. But that's not what we're seeing here. There's no relationship between their reports of using the strategy and the extent to which they actually showed the effect. And so we don't think that the temporal repetition effect can at least fully be explained by a heuristic. But there is another possibility for sort of alternate explanation here, which is maybe that these memory representations for the repeated target images are just noisier. And what I mean by that is if you think back to the example that I gave about AI, or maybe we can even think about something more extreme, like if you're in the US and you know that George Washington was the first president. That's something that you've encountered many, many times. And so if you're trying to think back about when you first encountered that information, you might know that it was a really long time ago because you've encountered it so many times, but you're not going to really have a precise memory for when exactly you first encountered it. So if we think about the temporal repetition effect as sort of like a very micro scale, like transformation of memories to more like semantic representation of just, oh, you've always known this, then maybe what that might mean is that you're going to make repeated information, you're going to push it back in time because you know that you've sort of always known this. But you're not going to have a precise representation for when it happened. And so maybe that might be partially explaining our results here. And so we address this in a couple different ways. The first is that we can look at actual temporal memory. So we can compute the Spearman correlation between where participants placed each item on the timeline and when in the sequence the image actually occurred to get a sort of rough estimate of their sort of temporal memory accuracy. And so on this noisier memory representation account, you might predict that people are actually worse at placing the target items relative to the fillers. But we actually find the opposite result. So participants have significantly better temporal memory for the repeated targets than for the fillers, despite the fact that the targets were presented at multiple different points in the sequence. And the other thing that we wanted to understand was people's confidence. So maybe sort of going back to this like George Washington example, you know that it happened really long ago, but you don't know exactly when. You're not going to be very confident about when exactly it happened in time. But again, we find that participants are actually significantly more confident in rating their memory for when the targets first occurred relative to when the fillers first occurred. And this was just a very small pilot sample here, which is why there are fewer participants. But so in other words, we don't think that this effect can be explained by just noisier memory representations. If anything, people tend to actually have more precise memory representations for the targets than for the fillers. And then finally, I just wanted to note that the temporal repetition effect stands in contrast to many existing theories on how theories and data on how repetition influences temporal memory. So in particular, there's a huge body of prior work suggesting that when you repeat an event, you increase its memory strength. So basically, each time you experience the event, you're going to have a stronger sort of overall memory trace for that. And that should actually render repeated experiences to feel more recent. And in fact, there is a lot of evidence to support this, that if you ask people, when did you most recently see something, they'll rate the repeated thing as having occurred more recently in time than a non-repeated thing. So basically the opposite of what we've shown here. And And so what this suggests is that there might actually be separate mechanisms at play for remembering the when of when you first encountered something versus when you most recently encountered something. And this is something that we're actively trying to understand and try to sort of unpack why you might see both this pushing back in time of when something first occurred and this pushing forward in time of when something most recently occurred. And so we've run a couple different small pilots to try to get at this question here of why we might be seeing both effects. And so I'm going to be showing you data from a task in which, again, same encoding task as what I've shown you before, same sequences. But we just, at the memory test, not only asked people to indicate when they first saw the image, but we also then additionally asked them to report when they last saw the image. So again, for these fillers that were only shown once, that would mean that participants should be responding in the same point in time on both timelines because there were no repetitions. But for the targets which were repeated multiple times, we can get sort of independent estimates of when they think they first saw the image versus when they most recently saw the image. And so when we look at participants' responses to this question of when they first saw it, we robustly replicate the temporal repetition effect. Participants are placing these targets as having occurred earlier in time than their corresponding fillers. And critically, when we ask them when they last saw it, we see the opposite result. And so consistent with what other people have shown in the past, people are also rating the targets as having occurred more recently in time than the corresponding fillers. And I should mention that we sort of change up what fillers we're using here. So here the filler is the image right before the first presentation, whereas here the filler is the image right after the last presentation. So we're sort of still controlling for either initial encoding time or final encoding time. And so this is just to say that within the same task, we are actually seeing both opposing effects of repetition on judgments of primacy versus judgments of recency. In both cases, these effects are scaling with the number of repetitions. Because this was a smaller pilot here, that's why the error bars are so large, but you can see that the number of repetitions increases. As the number of repetitions increases, you're seeing a stronger temporal repetition effect here. And also you're seeing a stronger sort of recency effect, where the more times something is repeated, the more recent it is remembered to have last occurred. And so what this suggests maybe is that what repetition is doing is it might be stretching our memories along our timeline. For a given memory that was repeated, you're going to sort of push it back in time for its first presentation and push it forward in time for its most recent presentation. And if that's true, you might expect the two effects to be related to one another. The extent to which someone shows this pushing back, this temporal repetition effect, should predict the extent to which they show this pushing forward when they're asked to judge the recency of the item. And so we first looked at this in a cross-participants way. So just relating participants' overall evidence for the temporal repetition effect to their sort of recency effect. So numbers farther more negative along the y-axis are going to indicate a greater sort of most recent effect. So pushing forward in time for things, pushing forward in time for their sort of memory of when it most recently occurred. And numbers more positive along the x-axis are going to indicate a greater temporal repetition effect. So pushing back in time of things that were repeated. So what you would expect here is that you might see a negative relationship if these two things are correlated. So the extent to which people show a greater recency effect would predict a stronger temporal repetition effect. But actually, we don't find any evidence for such a relationship. These two effects are uncorrelated across participants. We can also ask whether they're related within a participant. So you might expect that across trials within a participant, there would be a relationship. But again, we don't find any evidence for that here. So here, each dot here is a participant, and along the y-axis corresponds to their sort of within subject correlation, but we don't find a relationship here. So just to sum up this part here, we found that repetition can make events both feel more distant when we ask about their first repetition and more recent when we ask about their last repetition. Critically, though, these two effects are not related to one another, either within or across individuals. And so this sort of leads us to this, still this question of what is explaining both effects? Why are we getting sort of opposing effects of repetition on memory for when something first occurred versus when it most recently occurred? And so we're really trying to actively think through this and sort of brainstorm what we can do to try to tease these things apart. And I'd be really interested to sort of hear any thoughts that you all have. But just to sort of talk about a couple of things that we're thinking of. One is we want to understand whether either of these effects, so maybe you can imagine that one effect is and one effect isn't, or they both are they an effect of encoding or an effect of retrieval? So is there something happening at the time of encoding as you're viewing these repeated images that's either causing the temporal repetition effect or the recency effect? Or are these effects of retrieval? Is it something that at the time of the memory test, you're sort of thinking back to the repetition structure and that's causing you to respond in one way or another? So when are these effects actually emerging and playing out? And this is something that I think is sort of best addressed with neuroimaging studies where you could actually relate activity at encoding and see if that predicts participants' responses during the retrieval task. And also, we're exploring some different neural network modeling to try to see if we can tease apart when these effects might be happening. And then another sort of semi-unrelated thought here is just how do these effects change over time? So I presented evidence that the temporal repetition effect can emerge over the course of days. So if you repeat items over many days, you see the effect. So one question just is, do we see that for the sort of most recent effect? Are we going to see that emerge over the scale of days as well? And also, what is the effect of sort of time or sleep between the encoding and the retrieval? So what is repetition, how when these repetitions are sort of consolidated during sleep, how might that change the effects on memory? So that's something that we're interested. It might not bear anything on the sort of two effects, but that's just another direction that we're hoping to take this. And so on that note, I just want to end on this idea that I presented at the beginning of the talk, which is that our memory for time is illusory. And what I hope I've convinced some of you of today is that we might need to sort of rethink how we think about the way that that time is encoded into memory. And perhaps think that maybe time is not something which is directly encoded into memory in the first place, but rather that time is something which is constructed or dynamically reconstructed from our memories. And so with that, I just wanted to mention the paper, not the recency primacy stuff, but all the stuff before that was published just a couple months ago, so you should feel free to check that out. I wanted to thank my co-author, Sherman Yousif, and I also just wanted to mention we both just started labs at Ohio State, and we'll both be recruiting graduate students this cycle. So feel free to check out either of our websites and definitely be in touch or put us in touch with people who you think might be good fits. And yeah, thank you so much for having me and for listening. And I'm happy to take any questions or hear any thoughts.
Thank you, Brynn. All right. I will watch the participant list and anyone can raise their hand if they've got questions for Brynn. Martin.
Hey, Brynn, great talk. Very exciting to see the additional data that you show. I'm surprised that there's no correlation between the initial start of these events and the end of them. But in the correlation plot you showed, it looks like you're collapsing across the number of repetitions. And so I'm wondering if you tried breaking down that scatter plot by the number of repetitions across the different items.
Yep. Yeah. So yes, we did it by repetition, and we also did it by like all of the different not just like 2, 3, 5, but also like all of the different possible combinations of repetition. So all of the different like block structures. So it could repeat in like blocks 1, 3, and 5. It could repeat in blocks 2 and 4. And across the board, we don't see any relationship.
Okay.
Yeah.
Okay. Pat.
Thanks. Yeah, that was great. That was really interesting. And I'm just down the road actually at Oberlin College near Cleveland. But I was thinking before you even presented the recency stuff, I was like, here's a possible way you do this. when you see something several times, you have a heuristic when you're asked about when did they occur. Well, I must, let's just say, spread those out over some interval. And so the more stuff that repeats, the more you spread that out uniformly across the interval. So your first instance of it should always move earlier.
Mhm.
But, and then I was like, yeah, but I think that means that your most recent thing would seem more recent perhaps because you know, or at least wouldn't seem earlier. And then you showed the effect. So I was like, I wonder if that's just sort of a simple heuristic that we use, and it doesn't apply to the fillers. You only see them once, so and you have a very noisy sense of when they occur. I wonder if there's sort of a regression to the mean for the fillers. Do they? No, you said that they're shifted. Well, anyway, that was the heuristic that I thought about. And maybe people are using something that simple that they just see something that's repeated and assume essentially that it's distributed equally across an interval of the task. And that makes the first one seem earlier and the last one seem later.
Yep. Yeah. And we definitely thought that that heuristic account might be explaining it. And we don't want to fully reject the heuristic idea, but because we don't see this relationship between the extent to which people report sort of using that strategy and the effect, we don't think there's very strong evidence for the heuristic. But you're right that we haven't run that version for we haven't asked people about their strategies when we ask about both the first presentation and the most recent presentation. So it's possible that we would see people sort of having insight into like a stretching mechanism, like a stretching and the extent to which they report, sort of using the repetitions to make their judgments. But also the fact that they're not correlated with one another, I think is puzzling, because I think if it is true that they're sort of using a heuristic of, oh, I'm just going to sort of equally distribute, then you would expect that the extent to which you see the temporal repetition effect would predict the extent to which you see the sort of most recent effect. But we don't see that there, which makes us think that maybe these are at least partially unrelated effects. But to your point about the fillers just sort of being a regression to the mean, I fully, I totally hear that point. And I do think that it's hard to disentangle whether our effects are driven by the targets or by the fillers, because we can only look at a comparison between the two. And it is possible that people are just worse at remembering the fillers. And that's basically, it's like a regression to the mean for the fillers rather than like a pushing back in time for the targets. I think it's hard to say which of those two effects is at play here, though there definitely is an effect of repetition on memory since we see a difference there.
Yeah, so could I just ask, the heuristic that you proposed and the one that I just explained, were they the same heuristic?
I was sort of interpreting them as the same, but maybe I misunderstood.
I I could be misremembering what your heuristic that you presented was, but I thought what I came up with was different. It does use the number of repetitions, but and you know we could talk offline perhaps.
Yeah.
Like I say, I'm down the road.
Yeah.
But yeah, I thought my heuristic was different. I was saying you just assume that you have to spread these out over the course of the task, and so if that's what you do, you should get earlier things pushed back and more recent things pulled forward.
Yep.
Is that the heuristic you presented?
So not exactly, because we weren't doing it in the version where we were asking about both the first and the most recent. So here, I'll just pull it up.
Because I thought what you asked the participants was slightly different. It sounded like the question you asked them wasn't the heuristic I described.
Yeah, so the question that we asked was, on what proportion of trials did you use your knowledge of the image repetitions to estimate temporal position? So it's sort of ambiguous, but you could imagine that what you're describing, which is a sort of equal distribution, could like predict the sort of first half, the pushing back effect of the temporal repetition effect. So I was sort of seeing them as related heuristics, but you're right that like the way we might probe that is different.
Yeah, and I also don't know that they would know, right?
Yeah.
Like some people might think they're explicitly doing this, and others they're using it, but they don't know. But there's certainly no sign of it here. So okay, I think I'm clearer now. Thank you. Very interesting.
Okay, Virginie.
You okay? Can you hear me?
Yep.
Yeah.
Thank you for a nice talk. It was nice and a bit dense, a lot of data. So thank you. It went a bit fast. I actually jump on what Pat was just mentioning about the regression to the mean effect. I think you might be interested in Arnaud d'Archambault using a sort of a paradigm in which you have these sequences of images or movies show some regression to the mean effect in the temporal recall, which might go into in line with what you showed. I also had the same question as Martin had in terms of recency, but I guess you already answered it. So the one I would bring up would be more theoretical. When you mention, you started by saying that there was no such thing as time-stamping mechanism, maybe, and that you're reconstructing memory in time, which I would agree with, but you still need some form of time-stamping anchoring of some form. So that would be my first question. And then the second question is more on the timeline. So in all of the interpretations, you seem to assume that the timeline that a priori would be created in the brain, in the mind of a participant, has the same resolution. So you interpret everything with respect to a fixed temporal resolution of that representational space. And we know that there's a lot of scaling going on nowadays in this temporal representation. So I wonder whether you could entertain having changes in the timeline resolution to account for your effects.
Interesting. Yeah. So so with respect to the timestamping question, so yes, I think what I mean when I say there is that there's no sort of intrinsic mechanism for encoding time directly, but I would argue that we have a sort of temporal context representation. So we are able to encode the order of events, and that's going to come along with sort of a representation of how context was changing over time. So spatial context, sort of, you could think of mental context. And then when you're trying to reconstruct time, you're sort of pulling up those context representations, which are sort of intrinsically related to sort of memory and what was happening at the time, rather than pulling up a temporal representation specifically. So that's sort of how I think about it. So sort of a retrieval of temporal context. And in terms of the sort of different like distortions of the timeline, I think that's a really interesting question. And in part, that's why we so first, by having sort of all within participant measures, we were hoping to sort of just wash out any sort of individual differences in the timeline usage, and like our Spearman rank correlation should be sensitive to any individual differences in timeline usage because we're just looking at the relative placements. And then similarly, because we designed it so that it was always a comparison between a filler and a target, which were presented at which were basically encoded at the same time, that was sort of our way to try to, again, account for any like broad distortions. But it is true that there might be, there's probably a lot more richness to unpack in the data in terms of whether there are other sort of more general distortions of time that we might be sort of looking over here.
Could I, because I'm on stage, so could I?
Sure.
Could you perhaps comment a little bit on the compression of information in the kind of experimental work that you are doing here? How is that affecting in some way the displacement in time? So how do you see the two interacting?
By compression, do you mean?
So the information that you're placing in memory in these between the feeder and the target, do you expect them to be compressed in the same way in memory, or do you expect a differential aspect due to the repetition? So for instance, in the encoding period, there were these hypotheses in time research during the encoding that repetition is going to compress, which leads to dilation of non-repeated measurements, for instance, right? So the surprise dilated. But the opposite could also be true, that the repeated information might be more compressed So would you see the same or the symmetrical effects when it comes to the recall?
Yeah, that's interesting. I would have to think about that more, but one thing that maybe speaks to it, though I might, you can tell me if you don't feel this way, but because we see when we ask about the most recent versus the first presentation, and we see that repeated things are both pushed earlier in time and pushed forward in time when you're asked about most recent, that would actually make me think that they're sort of the opposite of compressed, which they're actually like expanded over your timeline relative to the fillers, which actually might be compressed to sort of the regression, that sort of regression to the mean effect. But I would have to think about that more. That's a really interesting question.
Thanks. I've got a bit of a question as well. So thinking more about the heuristic that you were exploring, if you're a hammer, everything looks like a nail, and if you're a Bayesian, everything looks like it's Bayesian. But I guess what I'm wondering about is, like, if we based our priors on the assumption that what we're looking at is truly a random sequence, then you would see that expansion, sort of like Pat was discussing. But then you would expect it to correlate between the recency effect and the first effect if it was about how strong your prior was. On the other hand, if it was about how precise your measurement was, then maybe some people have more precise measurements of when something first happened, and some people have more precise measurements of when something last happened. So one thing I guess you might look for in the data would be correlations between precision of answering each of those questions and the biasing effect.
Yep.
Does that make sense?
Yep, that's a great idea. So I had shown that people were more accurate in terms of like temporal memory for the targets versus the fillers this is just data from the first experiment where we showed the temporal repetition effect. But in the version where we asked both about the first presentation and the most recent presentation, we saw that temporal memory for both judgments was more accurate than for the fillers. But I haven't related that to the actual effects.
Right. I guess looking at that across participants and saying, like, do the people who are the most accurate in the first memory thing show less of the expansion effect? Because the prediction would be that the people who are more precise would rely less on the bias that things tend to be uniformly distributed through an interval.
Yep. Yeah, that's a really interesting point. I can definitely look at that.
Okay, I'll leave the floor open for a bit, and I think I've got another one on the burner if nobody else wants to. So I guess I have one question about the encoding idea. What you would be looking for would be, it probably would not be brain activity at the encoding of the first occurrence, right? Because those are the same between the filler. And so the question is there a correlation between something that happened in the second and third repetition and that effect? Got it.
Yep.
Okay.
Yeah. So the way that we're thinking, so there's this idea of recursive remindings that has been sort of used to invoke or sort of invoked in thinking about the recency effect, though it's the connection there is a little tenuous there. But the idea is that every time that you see a repetition, you're sort of brought back to the previous repetition. So you're sort of reactivating the previous instances of when you saw it in memory, and that might be somehow causing one or both effects. So you can imagine what the analysis that we're sort of thinking is, at the sort of second or third repetition, do you see like a reactivation of the representation for when you first encoded the image? And is the extent to which you're sort of reactivating or maybe even like separating those representations, is that related to one or both of these effects?
I see. Yeah, that makes sense. And so you wouldn't be comparing it to encoding of the filler image, you'd be encoding it. You'd be looking for correlations between the second and third. Okay.
Yep.
And do you know where in the brain you'd want to look?
would be inclined to look in the hippocampus, in part my own bias of studying the hippocampus, but also the hippocampus is very implicated in time and temporal memory and holding on to temporal context. But I would definitely be also very open to exploring where you might see this more broadly.
Great, thanks. Anybody else have any questions? Pat's back.
I'm back. I'm sorry. I just wondered if you'd heard of the work of Bill Friedman. He has a 1993 paper looking back at memory of events in the past and finding that everything falls apart around 6 months into the past.
Yeah, I have read that paper, but I don't. I have to remind myself of it. Because that paper is a very like broad. The one I'm thinking of at least is like a very broad review of like temporal memory and all the different things that can affect it. So maybe we're thinking of different papers, but I'll have to revisit it.
Okay, I was just curious. He was an Oberlin professor as well, and
Oh, cool.
retired right when I arrived here. But as I recall, what I took away from this paper is that your temporal memory of an ordering of events, if they aren't on a sort of chronological calendar, that people have that, but if you don't pin it down beyond about a 6-month time window, your sort of memory of when it happened is essentially just gone. You can tell maybe it happened when I was an adult or when I was a child, but beyond that, beyond 6 months, it's very interesting. But I didn't think that it seemed very related to this work specifically because these stimuli are, few minutes apart at most. Yeah. All right. Thank you. Very interesting talk.
Yeah. Thank you.
Okay, well, if we don't have any other comments or questions, then I'll thank Brynn one more time for a really thought-provoking and interesting presentation. And we will see you next time. Let me just quickly, next time will be October, believe it's October 29th, unless I'm mistaken, and we will be sending out more information about that very soon.
Thanks so much.
Thanks,
Bye,
everyone.
everyone.